Hi everyone, I'm going to discuss using definition of terms from trigonometric function values for us to come up with the idea on the different trigonometric identities. So let's begin with reciprocal identities. Now, the reciprocal of any non-zero number, for instance, x is 1 over x. So, for example, the reciprocal of 5 is 1 over 5 and the reciprocal of 7 over 9 is 9 over 7. Now there is no reciprocal for 0. Scientific calculation have a reciprocal key. Usually this is labeled as 1 all over x, or you see x raised to the negative 1 power. Now using those keys, since the reciprocal of any non-zero number extend in the displays, so we have the idea on the reciprocal identities such that sine theta is equal to 1 all over cosecant theta. Tangent theta equals 1 all over cotangent theta. Cosine equals 1 all over secant. Cosecant equals 1 all over sine theta up to secant theta equals 1 all over cosine theta. Now, with the idea on the reciprocal identities, let's work on this example. So using the reciprocal identities, find each function value. So cosine theta, if secant theta equals 5 thirds. Now, we know that cosine theta is the reciprocal of secant theta. So cosine theta is equal to 1 all over secant theta. Now, substituting the value of secant theta, we have 1 all over 5 thirds. So basically, we just get the reciprocal of 5 thirds and really come up with cosine theta equals 3 fifths. Now, we're asked to solve for sine theta if cosecant theta equals negative square root of 12 all over 2. So we have sine theta equals 1 all over cosecant theta. So this is equal to 1 all over negative square root of 12 all over 2. So this is equal to 2 all over square root of 12. But do not forget, I'm sorry, the negative sign. So we have sine theta equals 2 all over negative square root of 12. So rationalizing the denominator, we got 2 square root of 12 all over 12, wherein square root of 12 is equal to 4 times 3. So we can extract square root of 4. So we have 2 times 2 here times square root of 3 all over 12. So this is 4, and then we have 3 here. So sine theta equals square root of 3, negative square root of 3 all over 3. Now, signs and ranges of function values that we have to know. In the definitions of the trigonometric functions, r is the distance from the origin to the point xy. So distance is never negative. So r is always greater than 0. Now, if we choose a point xy in quadrant 1, then both x and y will be positive, and the values of all six functions will be positive. Apart xy are in quadrant 2 has x less than 0 and y greater than 0. So this makes the values of sine and cosecant positive for quadrant 2 angles, while the other four functions take on negative values. Now, similar results can be obtained for the other quadrants as summarized in this table. So, we should be guided by the signs and the ranges of function values. Now, we're asked to identify the quadrant or quadrants of any angle theta that satisfies sine theta greater than 0 and tangent theta is less than 0. Now, since sine theta is greater than 0 in quadrants 1 and 2, while tangent theta is less than 0 in quadrants 2 and 4, both conditions are met only in quadrant 2. Now, the ranges of trigonometric function values for any single theta for which the indicated function exists. So take note that sine theta class is less than or equal to 1, but greater than or equal to negative 1, and cosine theta as well. Okay, so meaning if we're going to summarize that using an interval notation, if sine theta is less than or equal to 1, but greater than or equal to negative 1, so this is from negative 1 up to positive 1, including negative 1 and positive 1. So beyond the value of sine and cosine should be within that interval, including the boundaries. Tangent and cotangent theta can be equal to any real number. And then secant theta is less than or equal to negative 1, or secant theta is greater than or equal to 1. So this is like using the interval notation. This is less than or equal to negative 1. So this is from negative infinity until negative 1, union 1 up to positive infinity. Now, it's the same way with cosecant theta. So, this is from negative infinity up to negative 1, union 1 to positive infinity. Now, we have to decide whether a value is in the range of a trigonometric function. So, decide whether each statement is possible or impossible. For sine theta is equal to square root of 8. Now, for any value of theta, sine theta is less than or equal to 1, but greater than or equal to 1. Now, since square root of 8 class is greater than 1, it's impossible to find a value of theta with sine theta equals square root of 8. So, this does not fall in the range value of sine theta. Now, tangent theta equals 110.47. This is possible because tangent theta and cotangent theta can have any equal value, which is the set of real numbers. Now, secant theta equals 0.6. Since secant theta is less than or equal to negative 1, or secant theta is greater than or equal to 1, the statement secant theta equals 0.6 is impossible. Now, the Pythagorean identities can help us solve the missing values of trigonometric function. And these are the three Pythagorean identities. So we have sine squared theta plus cosine squared theta equals 1. Now, these identities were derived from the ratio of each sine, cosine, and tangent. For example, um, we know that, so from the Pythagorean formula, we have x squared plus y squared equals r squared. If we're going to divide each of these term by x squared, so we get 1 plus, so this is the same with y all over x squared equals quantity r all over x squared. Now, we know that the ratio of y over x is tangent, and this is 1 plus tangent squared theta, and r over x is secant squared theta. So we got 1 plus tangent squared theta equals secant squared theta. Now, if we're going to divide each term this time by y squared, so this becomes quantity x all over y squared plus 1 equals, this is cosecant or r all over y squared. So x all over y is cotangent, then squared theta plus 1 equals, so this is r over y is cosecant squared theta. So we got this one. And as we divide x squared plus y squared equals r squared by r squared, so we have this r squared. So this is equal to x all over r quantity squared plus y all over r quantity squared equals 1. So this is cosine squared theta plus sine squared theta equals 1. So these three identities were derived from this. Now, using the Pythagorean identities, this will help us solve for the missing trigonometric function values. So this time, we're going to solve for the missing or trigonometric function values given one trigonometric function. So if secant A equals negative 3 halves and tangent theta, or tangent A rather, is greater than 0, find the value of the other trigonometric function values. Now, take note that now we can solve for cosine A here by working on the reciprocal identities, and cosine A is equal to 1 all over secant A, which is equal to the reciprocal of negative 3 halves, which is negative 2/3. Now we already have cosine A. We can make use of the Pythagorean identity sine squared A plus cosine squared A equals 1. So substituting negative 2/3 here, we have sine squared A plus square of negative 2/3 equals 1. Transposing this on the other side, we have sine squared A equals 1 minus 4 all over 9. And extracting the square root, we have sine A equals positive negative. So this is 9 all over 9. So we have 5 minus 4. And 9 minus 4 is square root of 5 all over 3. Since cosine A is less than 0, class, and tangent A is greater than 0, A must be in quadrant 3. So this means that sine A must be negative square root of 5 all over 3. So we have sine here, we have cosine value and the sine. So we can solve for tangent by using another trigonometric identity. Now we can solve for tangent theta by working on tangent squared A plus 1 equals secant squared A. So we know that secant squared A is 2/3. So we will just substitute the value here, transpose 1 on the other side. So we will square negative 2/3. And then we have minus 1 here. So we have tangent squared A equals 9 all over 4 minus 1. So extracting the square root, we have tangent A equals, so 1 is 4 over 4. So 9 minus 4 is 5. So we have positive, negative, square root of 5 all over 2 here, since square root of 4 is 2. Now, tangent must be greater than 0. So tangent has to be square root of 5 all over 2. So we know what's sine theta. So therefore, cosecant theta or cosecant A must be equal to negative 3 all over square root of 5, or this will be negative 3 square root of 5 all over 5. So we have the value of cosine, secant, sine, cosecant. We have tangent here, and cotangent is the reciprocal of tangent. So this is 2 all over square root of 5, which is equal to 2 square root of 5 all over 5. So tangent B is 1/4, and the terminal side of B is in quadrant 3. Solve for the values of the other trigonometric functions. Now, we can make use of the Pythagorean identity tangent squared B plus 1 equals secant squared B. Since tangent B is 1/4, substituting the given in the equation here, so we will square 1/4 plus 1 equals secant squared B. So this is 1 all over 16 minus 16 all over, plus rather 16 all over 16. So we have secant squared B here. So extracting the square root of both sides, we have square root of 17 all over 4. So this is positive, negative equals secant squared, secant B. So secant B equals positive, negative square root of 17 all over 4. Now, in the condition here, the terminal side of B is in quadrant 3. So in quadrant 3, tangent and cotangent are positive. So the rest are negative. So secant B must be negative square root of 17 all over 4. So we know what secant B, we can solve for cosine B. And cosine B is equal to negative 4 all over square root of 17, which is equal to negative 4 square root of 17 all over 17. Now, we can solve for tangent here. using another identity. Since we know what's the value of cosine b, we can solve for sine squared b by working on this Pythagorean identity. So, transposing cosine squared b on the other side and substituting the value of cosine here. So, we have sine squared b equals 1 minus quantity negative 4 square root of 17 all over 17 squared. And extracting the square root of both sides, we come up with sine b here equals 1 all over square root of 17 because this one is equal to 16 over 17. So when you less 16 over 17 from 1, you'll have 17 over 17 less 16 over 17. So this is 1 all over 17. Extracting the square root will come up with 1 all over square root of 17. Rationalizing the denominator, we got sine b equals negative square root of 17 all over 17. So we know sine b, the value of sine b, the value of cosine b, as well as secant b, tangent b. Working on cosecant b is done by getting the reciprocal of sine b. So this is negative square root of 17. While for cotangent b, so we have secant and tangent here. So by from for cotangent b, we'll just get the reciprocal of tangent, which is 1/4. So cotangent b is 4. So working on the Pythagorean identities, we'll be able to solve for the missing trigonometric function. Now we have these quotient identities. So sine A here equals all over cosine A is tangent A. So by working on the ratio of sine A, we know that sine A is equal to y all over r, and cosine A is x all over r. Simplifying this complex fraction will lead to y all over x. And we know that y all over x is tangent A. So likewise here, this is x all over r all over y all over r. Simplifying the complex fraction, we got x all over r, which is equal to cotangent. So these identities will help you class solve for the missing trigonometric function values.